Hey everybody, today we'll do another short video, and today we'll do a quick tutorial on how to do a small project with the ultrasonic distance sensor. And I want to see if I can actually do a little diagram here just to show just to show how this works real quick, because other other way to do it would be to actually show a graph on some type of I would say, like, maybe some type of graphical in another type of software, different, but at this point I don't have any, so I'm gonna go ahead and just do it as much as we can, just by actually seeing what we can do here. Like, for example, so let's say that we have something like this, all right, and I have the little right, like that, right? So let's pretend that this is the distance sensor, right? And up here we have an object, right? So what it does is send us a signal within 4 meters. This can actually reach up to 4 meters, and it goes like this, send the signal somewhere within that distance, and then that signal bounces back to the module. It goes back to the module, right? Then it reads. So it has 4 pins all together. It has the ground, it has the 5 volt, it has the trigger, and it has the echo pin. So it sends a signal, and then it bounces back and reads. So this, let's say for example, that this here is just the distance, right? So there will be some distance D. Right? So it goes back and forth and then read a certain distance, right? Okay, so how this read? Well, it is, and the sounds, it sends sound waves at 40,000 hertz per second. That's a lot, right? So that's a lot. So what it does is send us. It sends us the waves, right? And that's why it's called ultrasonic. And then it reads, right? It reads and it senses something and bounces back and then it reads, right? So how we calculate, right? So speed. Oops. Let me get rid of this. Okay, so the speed of sound, right, is equal to 343 meters per second, right? Now, if that is the speed of sound, I mean, you can Google that, you can find that out. Then we usually, in these microcontrollers, we actually go to the lowest times, you know, the units of time you can get, which sometimes is microseconds, right? So we know that the speed of sound is, by seconds, is 343 meters per second, right? Now, how we calculate the speed on microseconds, right? So let's say a speed in microseconds, right? So we know that is 343 meters per second. So 343 meters per second, right? And then we times that by what? We times that by, because we need to get rid actually of seconds, right? We want to use what is called microseconds. And how many microseconds are in a second? Well, there is a lot actually. But for right now, we want to turn this into, so we don't want to get rid of meters, right? So how do we get rid of meters, right? So meters. Now, what it would be, okay. So let's take a step back, right? So to measure in meters is a lot, right? It's this big pieces. So because only 4 meters, this reaches only 4 meters. Let's do it in centimeters. So how do we do in centimeters? How do we get centimeters for this? Well, we have 300, and I already made it mistake here, okay? So 343 meters per second, right? So how many centimeters do we have in a meter? Well, we have 100, right? So we multiply by 100 centimeters, because we want to read it in meters. We multiply by 100, right, over a meter, 1 meter, right? And then we write here centimeters, correct? Now, we want to get rid of seconds, right? So we have to kind of do it in microseconds, right? We want to do the microseconds. Of course, you can do it in the Arduino in the seconds, but it sometimes give you a little trouble when you use the delay time in seconds. So it's better to do in microseconds. Okay, so let's do this. So we have that, right? Now we know that to get that, we have to multiply, right? So how many seconds actually do we have in? Okay, 1 second has 1 second, okay, 1 microsecond, I'm sorry, 1 second is equal to 1, oops, let me just, okay, so let me just do this here. Okay, so the bottom line is that you do it like this, right? So 1 second, 1 second is equal to 1 over 2, 3, 4, 5, 6. Right? So this is 1 second, right? Which when you divide that, you get the following. You get the same thing as scientific notation as saying 1 times 10 to the minus 6. Right? Same thing, right? So when you do this math, alright, so this is just to show. Alright, so I'm going to get rid of this. So, okay, now when you do the calculation, and this is equal to what? It's equal to the speed in centimeters per microsecond, right? The speed is, okay, so, oh yeah, you know what, let's do it this way, because we need to get rid of this. So that is, I mean, let's do it like I just show you guys the same thing. So see, when we do math, we need to kind of be clear what we're doing, right? So here, right, so we have 1 second, and then we have like that, right? So and this will give us microseconds, right? So what happened here is the following. So in 1 second you have this many microseconds, right? So, and you write microseconds like that with a mute. Okay, so this cancels out. Right? So this M, I don't know, something is weird here. Okay, so this M cancels out, that one cancels out, this S cancels out, that one cancels out, and you end up with what? You end up with 0.0343 centimeters per microsecond, right? Which is kind of, it's a mute. This is a mute actually. Alright, so this is a mute. So that's kind of weird looking thing, a microsecond, right? Okay, so that is basically what we need, right? So the speed of the sound now is in centimeters per microsecond. Okay, so let's go a little quick. Let's show the hardware that we have. The hardware. As you can see, this is the ground. This is the ground, this is the trigger, this is the echo. The orange is the trigger, and the brown is the echo, and the green is the ground, and the red is the 5 volt, right? So that is the hardware part of it. Now let me okay, now this right here, is the code. This right here is the code that that we actually wrote for this. So okay, so this is the code, right? So constant int, so include software serial, right? And then the constant int, echo pin on number 10, constant int, trigger pin in number 11, and distance and then duration. This will be the time, because we need the time to do the calculations, right? Now let's go and let's go to this here, right? We know that distance is equal to rate times the time, right? So now to get the time, what we do, we divide by the, to get the time, right? We divide by rate over the distance, right? So okay, so then what we do divide by r, and we get time is equal to distance. That's not good. Distance, and this, because this is not, let me just get rid of the whole thing. Alright, so time time is equal to d over r, right? Over the rate. Okay. So how do I actually calculate, for example? For example, let's say, for example, that the distance is 20, right? Distance is 20 centimeters, right? So t equal to what? Equal to 20 centimeters over what? Over the rate. Over the rate, right? Which is what? Which is 0.34343 centimeters per microsecond, right? Okay, so basically those cancel out. If you do the math, those centimeters will cancel out, and you will get what? You will get about 500. This, for example, $583 centimeters centimeters. I'm sorry. You will get microseconds. You will get microseconds because you're looking for time. Microseconds. Microseconds, right? About 583 microseconds. That's what you will get, right? And I'm sorry about that. Doesn't look like this is. I got a lot of stuff here, and I don't have a lot of room to. Okay. Okay. So. Bottom line is this is equal to 583 microseconds, right? So 583 microseconds, right? Okay, so that would be the calculation for the time, right? This is one example, right? Because we need time to calculate the distance, right? Okay, so let's go back to the code. Okay, so we do that, right? We declare okay, so we declare distance int and long for duration for time, and then we come here and then we say, of course, in Arduino you're gonna say P mode, echo, input, P mode, trig, output, trig pin is output, and echo pin is input, right? Then the rate, the bit rate was set up to 9600, and then we come back here and we just write a little code. Digital right, trig pin low, we start a low, and then we said delay microseconds to, and then we just do digital right, trig pin 10 seconds, you can put 10 seconds, digital right, pin low, we go back to low, on the trig pin, then the duration here, you do duration pulse in. The pulse in will take at the moment that this pin is high, it will pulse it in, right? It will pulse in that pin and set it up to high, right? It will, okay, and then it will come here, well, it will calculate the distance. And of course I am missing something here, I'm missing a 3, sorry. Actually, no. 343, right? Just like that. Okay, now here, what I did was, because the way that I have this set up, see I have a lot of space here. See that? In this, so what I did was I put an if statement. I put an if statement here, right? So I said the duration pulse in, right? And then the distance, which is that the calculation, which is the time times the rate, right? And divided by 2. Because that is divided by 2 is signal out and then signal in, right? So okay, so we divide it by 2. And the distance, if it's less O of 100, right? If it's equal to less than 100, because if you know, my table, I don't want to be in the air doing like this with a piece of, paper. So I set up, if the distance is greater than that, then and then just do what is called the print out of, if it's less or equal to, then do the print out the distance, right? Print out the distance. Else, print out the outer range, right? So let's upload this in the Arduino. And okay, it seems like everything went good. But if I have some issues with this, you gotta forgive me because I got some hardware problems. Hopefully, I got some of this wire, they are kind of loose. And that's, that is part of this thing though. A lot of times, everything should, it seems like everything is fine, but little thing that goes wrong, a wire can be loose, and you don't get the result that you're looking for. Okay, so let's do, and it's sensing something. Maybe I don't know. We will see. Probably it's the camera. I think it's the camera. I think it's the camera because it's in that same direction, and I don't want to move it because if I move it, probably it's going to get the wires all messed up again. You can see see where the envelope is? Let me get this camera out because I think it senses the camera. See, now it says everything right now it says out of range because it was sensing the camera. So, but it seemed like, I don't know. And again, this is because, like I said, I was having some hardware issues. But, okay, so it is right now. See? It's about 63. If I go far and far. Okay, so right here it says out of range. Yeah, out of range. I'm going close. 86. I'm getting close. I'm getting close to the. I'm getting close, closer and closer, and if we're in the distance, as you can see, the little ruler right here. That little ruler is what? The little ruler is that ruler is 15 centimeters. So if I go close to the ruler, that ruler is 15 centimeters. 20 centimeters. Here you go. Here you go. See that? Yep, very close. 15 centimeters. Yep, so it's working. So that's it, guys. That's it for this tutorial. I hope you learned something. Maybe eventually we will do something else with it. So yeah, that's how you do it. So to calculate, like I said, to calculate the distance, so we have the time, right? Let's say, for example, you have the time. Now, the distance, all you do is, so distance equal to, in this case, time, which is time, right? Duration, right? Right? Times 0.40343 over what? Over 2. And this is what? This is centimeters microseconds. You take that and divide it by 2 and you get your distance, right? Okay, so that's it, guys. That's it for this tutorial. That's how you do it. And let me know if you have any questions. Just subscribe and subscribe and like. Give me a thumbs up. Thank you for watching.